The history of video game development dates back to the early 1950s, when computer scientists began creating simple games as part of their research. One of the first known video games was Space War, developed in 1962 by Steve Russell at MIT. This marked the beginning of an era that would revolutionize entertainment and technology. As technology advanced, so did the complexity and capabilities of video games. The 1970s saw the rise of arcade games like Pong and Space Invaders, which captured the imagination of players worldwide. The introduction of home gaming consoles such as the Atari 2600 in the late 1970s brought video games into households, further fueling the industry's growth. The 1980s and 1990s were golden eras for video game development, with iconic titles like Super Mario Bros., The Legend of Zelda, and Final Fantasy becoming household names. These games pushed the boundaries of what was possible in terms of storytelling, gameplay mechanics, and graphics. The turn of the millennium marked a significant shift towards three-dimensional graphics and immersive gameplay experiences. Game developers began utilizing advanced rendering techniques and physics engines to create realistic virtual worlds. The introduction of online gaming and multiplayer capabilities further transformed the industry, allowing players to connect and compete globally. Today, video game development continues to push the boundaries of technology, with advancements in artificial intelligence, virtual reality, and augmented reality. Games like Fortnite, Minecraft, and The Witcher 3 showcase the incredible creativity and innovation present in the industry. The history of video game development is a testament to human ingenuity and the endless possibilities of virtual worlds. The evolution of virtual worlds in games has been a fascinating journey that has transformed the way we experience interactive entertainment. In the early days of video games, virtual worlds were limited to simple, two-dimensional environments with basic graphics and gameplay mechanics. However, as technology advanced, so did the complexity and realism of virtual worlds. One of the key milestones in the evolution of virtual worlds was the transition from two-dimensional to three-dimensional graphics. This shift allowed game developers to create immersive environments with depth and realism, enhancing the player's sense of presence within the game world. The introduction of three-dimensional graphics opened up a whole new realm of possibilities for game developers, enabling them to create vast, open worlds filled with intricate details and lifelike characters. Games like Super Mario 64, released in 1996, showcased the potential of 3D virtual worlds and set a new standard for immersive gameplay experiences. Another significant development in the evolution of virtual worlds was the advent of open-world games. These games offered players unprecedented freedom to explore expansive virtual worlds at their own pace, engaging in a wide range of activities and quests. Titles like Grand Theft Auto 3 and The Elder Scrolls Skyrim pushed the boundaries of what was possible in terms of world building and player agency. The rise of massively multiplayer online games, MMOs, also played a crucial role in shaping virtual worlds in games. MMOs like World of Warcraft and Final Fantasy XIV allowed thousands of players to interact in a shared virtual environment, creating dynamic and ever-evolving worlds. Virtual reality, VR, and augmented reality technologies have further revolutionized the concept of virtual worlds in games. VR headsets transport players into fully immersive 3D environments, where they can interact with objects and characters in a way that feels incredibly lifelike. AR games like Pokémon Go blend virtual elements with the real world, creating a unique and engaging gameplay experience. The evolution of virtual worlds in games continues to push the boundaries of technology and creativity, offering players endless opportunities to explore new and exciting digital realms. Game engines are the backbone of modern video game development, serving as the software framework that enables developers to create and deploy games across various platforms. These engines provide a suite of tools and functionalities that streamline the game development process, allowing developers to focus on designing gameplay mechanics, graphics, and content. One of the most popular and widely used game engines is Unity, known for its versatility and user-friendly interface. Unity supports both 2 and 3 game development and is compatible with multiple platforms, including PC, consoles, mobile devices, and virtual reality headsets. Another prominent game engine is Unreal Engine, developed by Epic Games. Unreal Engine is renowned for its cutting-edge graphics capabilities, robust physics engine, and powerful editor tools. It has been used to create some of the most visually stunning and immersive games in the industry, such as Fortnite and Gears of War. Game engines play a crucial role in optimizing performance and efficiency during game development. They handle tasks such as rendering graphics, managing assets, handling input from players, and implementing physics simulations. By providing a standardized framework and set of tools, game engines help developers save time and resources, enabling them to focus on creating engaging and innovative gameplay experiences. Game engines also facilitate cross-platform development, allowing developers to build games that can be deployed on multiple devices and operating systems with minimal modifications. This versatility is essential in today's gaming landscape, where players expect seamless experiences across different platforms. Additionally, game engines often come with built-in features for networking, audio processing, and artificial intelligence, further enhancing the capabilities of developers. The role of game engines in modern video game development cannot be overstated. They empower developers to bring their creative visions to life, pushing the boundaries of what is possible in terms of graphics, gameplay, and immersion. As technology continues to advance, game engines will evolve to meet the demands of an ever-changing industry, driving innovation and shaping the future of gaming. Graphics and rendering techniques play a crucial role in creating visually stunning and immersive gaming experiences. One of the key aspects of graphics in games is the use of shaders, which are programs that determine how light interacts with objects in the game world. Shaders are essential for creating realistic lighting effects, shadows, reflections, and textures, enhancing the overall visual fidelity of the game. Another important technique in graphics and rendering is ray tracing, a rendering technique that simulates the behavior of light rays in a virtual environment. Ray tracing enables developers to achieve highly realistic lighting and reflections, resulting in lifelike visuals that blur the line between reality and virtual worlds. Graphics processing units, GPUs, are essential components for rendering graphics in games. GPUs are specialized hardware designed to handle complex mathematical calculations required for rendering three-dimensional graphics. They are optimized for parallel processing, allowing them to render images quickly and efficiently. One interesting fact about graphics in games is the concept of level of detail, LOD systems. LOD systems dynamically adjust the level of detail in objects based on their distance from the player's viewpoint. This optimization technique helps improve performance by reducing the complexity of objects that are far away from the player, while maintaining high detail for objects in close proximity. Another fascinating graphics technique is procedural generation, which involves using algorithms to generate content such as terrain, textures, and objects in real time. Procedural generation allows developers to create vast and diverse game worlds without the need for manual design, resulting in dynamic and unique gameplay experiences. Graphics and rendering techniques continue to evolve rapidly, driven by advancements in hardware and software technology. The pursuit of photorealistic graphics and immersive virtual worlds pushes developers to innovate and explore new rendering techniques. As technology progresses, we can expect even more realistic and visually stunning games that push the boundaries of what is possible in the world of gaming. Artificial intelligence, AI, plays a significant role in shaping the gaming industry, enhancing gameplay experiences and creating more dynamic and immersive virtual worlds. In game development, AI is used to create intelligent behaviors for non-player characters, NPCs, enemies, and allies, making them more responsive and adaptive to player actions. AI algorithms enable NPCs to exhibit human-like behaviors such as decision-making, pathfinding, and strategic planning, adding depth and complexity to gameplay. One interesting application of AI in game development is procedural content generation, where algorithms are used to create game content such as levels, quests, and items. This technique allows developers to generate vast and diverse game worlds dynamically, providing players with unique and engaging experiences. AI-driven procedural generation can also help optimize game development workflows by automating the creation of content, saving time and resources. Another fascinating aspect of AI in games is machine learning, a subset of AI that enables computers to learn from data and improve their performance over time. Machine learning algorithms can be used to create adaptive game systems that adjust difficulty levels based on player skill, personalize gameplay experiences, and enhance player engagement. AI-powered game development tools, such as behavior trees and decision-making systems, empower developers to create more sophisticated and realistic game worlds. As technology continues to advance, we can expect AI to play an increasingly prominent role in shaping the future of gaming, driving innovation, and pushing the boundaries of what is possible in virtual worlds. Sound design and music composition are essential elements in creating immersive and engaging gaming experiences. Sound design involves the creation and implementation of audio assets such as sound effects, ambient noises, and voiceovers to enhance the atmosphere and realism of the game world. Sound designers use a variety of techniques, including Foley recording, digital synthesis, and audio processing, to craft unique and dynamic soundscapes that complement the gameplay. One interesting fact about sound design is the concept of spatial audio, which simulates the perception of sound in a three-dimensional space. Spatial audio techniques, such as binaural recording and positional audio, help create a sense of depth and directionality in the game's sound environment, enhancing the player's immersion. Music composition is another crucial aspect of game development, setting the tone and mood of the game world. Composers work closely with game developers to create original musical scores that evoke emotions, enhance storytelling, and drive gameplay. Interactive music systems, where the music adapts to the player's actions and the game's narrative, add a dynamic and responsive element to the gaming experience. One fascinating detail about music composition in games is the use of leitmotifs, recurring musical themes associated with specific characters, locations, or events in the game. Leitmotifs help establish continuity and emotional connections throughout the game, enriching the player's experience and creating a cohesive narrative. Sound design and music composition are integral components of game development, contributing to the overall immersion, emotional impact, and storytelling of video games. Networking and multiplayer capabilities are integral components of modern video games, enabling players to connect, compete, and collaborate in virtual worlds. One of the key technologies that power networking in games is the use of dedicated game servers. Game servers act as centralized hubs that facilitate communication between players, synchronize game states, and manage multiplayer sessions. By offloading the computational workload to servers, game developers can ensure a smooth and seamless multiplayer experience for players. An interesting fact about game servers is the concept of server tick rate, which refers to the frequency at which the server updates the game state. Higher tick rates result in more responsive gameplay and reduced latency, providing a smoother experience for players. Another essential aspect of networking in games is netcode, the underlying code that governs how data is transmitted between players and servers. Efficient netcode is crucial for maintaining synchronization between players, minimizing lag, and preventing cheating in multiplayer games. Peer-to-peer networking is another networking model commonly used in multiplayer games, where players connect directly to each other without the need for a dedicated server. Peer-to-peer networking can be advantageous for certain game types, such as small-scale cooperative games, but may introduce challenges related to security and scalability. Cross-platform multiplayer capabilities have become increasingly prevalent in modern games, allowing players on different devices and platforms to play together seamlessly. Cross-platform play requires robust networking infrastructure and careful consideration of input methods and performance to ensure a fair and enjoyable experience for all players. The rise of cloud gaming services has also revolutionized multiplayer capabilities, enabling players to stream games from remote servers and participate in multiplayer matches without the need for powerful hardware. Cloud gaming services leverage high-speed internet connections and data centers to deliver low-latency multiplayer experiences, opening up new possibilities for cross-platform play and social gaming. Networking and multiplayer capabilities continue to evolve and shape the landscape of video game development, offering new opportunities for social interaction, competition, and collaboration in virtual worlds. The future of video game development technologies holds exciting possibilities that promise to revolutionize the gaming industry. One key trend is the continued advancement of virtual reality, VR, and augmented reality, AR technologies, which offer immersive and interactive experiences for players. VR headsets like the Oculus Rift and HTC Vive provide a new level of immersion, allowing players to step into virtual worlds and interact with environments in unprecedented ways. AR games like Pokémon Go have demonstrated the potential for blending virtual elements with the real world, creating unique and engaging gameplay experiences. Another trend to watch is the rise of cloud gaming services, which enable players to stream games from remote servers and access high-quality gaming experiences on a variety of devices. Cloud gaming services like Google Stadia and Microsoft xCloud leverage the power of cloud computing to deliver low-latency gameplay and seamless multiplayer experiences. Artificial intelligence, AI, will also play a significant role in shaping the future of gaming, with AI-driven procedural generation, adaptive gameplay systems, and intelligent NPCs enhancing the depth and complexity of virtual worlds. As technology continues to evolve, we can expect to see even more innovative and immersive gaming experiences that push the boundaries of what is possible in the world of video games.